What is mass spectrometry? To make it seem very simple, mass spectrometry is the practice of taking a sample, like dirt from the bottom of a shoe, and breaking it down to identify compounds in that sample. This process of ionizing, using chromatography, analyzing, and detecting samples can be used in so many different ways. During COVID, while all of us were playing video games and binging Ted Lasso, mass spectrometers were used to analyze nasal swabs to help with the overflow of people needing testing at clinics. Mass spectrometers are also used to help identify disease, as it can identify biomarkers from human samples, like blood. After it sucks your blood, it detects proteins and lipids, and the mass spec detects diseases such as metabolic syndrome. After disease diagnosis, mass spectrometry is helpful in pharmaceuticals. It is useful to take accurate screenings for drug monitoring and overall safety. Lastly, I may be a little biased, but this one is my favorite. Mass spectrometry is used by many forensic analysts. With mass spec, trace evidence, such as fibers and polymers, can be sampled and analyzed to find any unknown compounds in a sample. Arson investigations use mass spec to identify possible accelerants used in the fire, as well as identifying explosive residues from bombings. Mass spec has a huge impact on how criminologists and forensic scientists can go about any case, because they are able to find the tiniest bits of evidence that make a big difference in convicting a criminal. Now that you know how mass spec is used, let's talk a little bit about what is actually happening inside. There are 3 parts to a mass spec. Number 1, the ion source. This first step is used to ionize the sample. Ionizing the sample is adding high heats to it before adding a bunch of electrons. Number 2, the analyzer. The analyzing consists of accelerating the charged ions through a long tube. The data collected is the TOF, or time of flight, basically how long it takes an ion to get from one side to the other. Light ions travel faster than heavier ones with the same charge. And of course, you all know the saying, the higher the charge, the faster the travel. Well, after you get the TOF and or distance, the last part comes into play. Number 3, the detector. While the ions are deflected by a strong magnetic field, the mass changes the trajectory of an ion. The detector detects, obviously, where the ions landed. Depending on the location of the ion, the mass-to-charge ratio, or M/Z, is determined. There is, I guess, one final step. When the mass-to-charge ratio is found, a machine spits out a graph where the x-axis is mass-to-charge ratio and the y is the relative intensity. The graph gives you every piece of information you could need from that sample. Well, if you are catching a criminal, it probably won't spell out their name for you. Some takeaways I hope you get from this video are: mass spectrometry is used for many different points of study. Mass spec uses manipulation of molecules to identify specific elements. There are 3 basic parts to mass spec: ion source, analyzer, detector. In the forensic world, this tool has helped to close many cases. Thank you.